This is the second video looking at calculus exam questions from 2024 back. In this question we have an ornament made of two cones. We can see one here and one on top. A vertical cross section of the ornament, so from C to D is this vertical cross section. And if we turn that circle around, we might be able to see that it's the diameter. And standing on the diameter we have an angle going to the arc of the circle. And any angle standing on the diameter is 90 degrees from your junior cert theorems, which are now taken off the course. So not many people might know that just off the top of their heads, but you would if you had done it from junior cert. So this the diagram is symmetrical about the line DC. State why this angle is 90. So stating it is the angle standing on diameter of the circle is equal to 90 degrees. So we take any angle standing on the same arc as well through the center. This is the center. Any angle standing on the same arc as this guy. So these points will be the same. If this is 2x, this one is half, this one is x. Similar type of maths involved. Then we're asked to show that two of the triangles are similar, and the two triangles are BCE, which is the top one, the bigger one, BCE. So similar triangles have the same angles. So let's draw that triangle here, BCE. We have a right angle in BCE. We'll label the angles 1 and 2. Then we have the second triangle, which is DBE, which is the smaller one down the bottom here. So are these triangles similar? Let's have a look. We have the right angle here, and we'll label these angles 3 and 4. And the starting point is the previous part. If this one is 90, this angle here, which is angle 1 down here, and this angle here 2, well actually it's angle 4 down there, I'll call it angle 4. Angle 4, 1 plus 4 have to be equal to 90 if this guy is 90, so we can start with that. Angle 1 plus angle 4 is equal to 90 degrees. And we also have in this triangle here, angle 1 plus angle 2 is equal to 90 degrees because of the right angle. So therefore, angle 4 is equal to angle 2. Has to be. And if angle 4 is equal to angle 2, the third angle has to be the same. Because we have a right angle and a same size angle. So those two angles, if 4 is equal to 2, 3 is equal to 1. Therefore, triangles are similar. A question that has come up on the junior cert the last 2 years. So similar triangles seems to be a trend that is emerging in these questions. Not much calculus involved here though. Those in the second part. So we're told in the next part, the top cone has a radius of r and a height of h. So EB is r and EC is h. So just have a look here. EB is r, which is this one here. And EC is h. Is that what they told us? EC is h. Okay, EC is h. And they've also told us that the sphere has a radius of 10. So this one h. So we just need to get into the other triangle. That one has to be r as well because both of them are along here. And if the sphere has a radius of 10, then this whole diameter is 20. So this one is h over here. This one here has to be 20 minus h. So which angles are the same? 4 is equal to 2. So angle 4 is equal to angle 2. So I'm going to change this to angle 2. And 3 is equal to 1. I'm going to change this to angle 1. And then we can match off the corresponding sides. So if I take side 1 to the right angle, that's h, over side 1 to the right angle, and the other one will be r. That's going to be equal to side 2 to the right angle, and this one is r, and side 2 to the right angle, and this one is 20 minus h. And if we cross multiply, we're going to get r squared is equal to 20h minus h squared. And then in the second part, we kind of have the calculus part coming in. Hence, write the volume of the cone in terms of pi and h. and find out the value of h that gives max volume. So we want to get rid of r in the volume of a cone. The volume of a cone is 1/3 pi r squared h. 1/3 pi r squared h, and they're saying to us get rid of r. We want it in terms of h, and we have r here in terms of h, and in fact we have r squared. So it's 1/3 times pi times r squared, which is 20h minus h squared, times the other h, and may as well multiply it out. We're going to get pi over 3 times 20h squared minus h cubed, and this is volume. So dv dh, let it equal 0, and we'll get the max value for h. So we have the constant in front, pi over 3, and if we differentiate 20h squared, we get 40h minus, if we differentiate h cubed, we get 3h squared. So if this expression is equal to 0, this guy has to be equal to 0. Pi over 3 is not. So 40h minus 3h squared equals 0. 40h, we could factor out the h at this point, or we could say 40h. Well, maybe it's good maths to factor out the h, because there's two values for h here. H times 40 minus 3h equals 0. H can't be 0. So 40 minus 3h is equal to 0. 3h is equal to 40. H would be equal to 40 over 3. Just check, do they want it as a decimal? No, they just say find the value of h. So I think 40 over 3, and we're dealing in centimeters in this question, I believe, centimeters. So 40 over 3 centimeters, the value of h, that will maximize the volume. This question is another trend they've been bringing in to applied maths. Kind of the applied maths guys know that s is equal to ut plus a half at squared is displacement. If we differentiate displacement with respect to t, well, what will we get? We'll get u plus twice a half, just 1, so at, which is equal to velocity. And if we differentiate, if we have velocity is equal to u plus at, dv dt, u being a constant will be 0, will just be equal to a, which is acceleration. So a tiny bit of knowledge with these three formulas will help in some of these questions that have been asked in the last few years. The first part here is work out Fiona's speed when she passes a. So v of 0, time will be equal to 0, she passes a. So you can see we're just going to get the constant at the end. 109 kilometers an hour. A nice easy intro. Find acceleration, that is the rate at which her speed is increasing, 5 minutes after she passes the point A. So t is equal to 5. So we have speed. How do we go from speed to acceleration when we differentiate it? So dv dt is equal to, if we differentiate 2/3 t cubed, we're going to get 2t squared minus 6t squared becomes 12t, and 13t just becomes 13, and we're subbing in 5. So v prime 5, 2 by 25 is 50, minus 12 by 5 is 60, plus 13 is going to give me 3 kilometers an hour every minute is the rate of increase. Find the value of t at which Fiona reaches her max speed. So the derivative will be equal to 0, so 2t squared minus 12t plus 13 equals 0. The temptation is to factorize, but it doesn't factorize, so the minus b formula, as you like to call it, or the quadratic formula, sub in your values here, and you're going to get two answers. T is equal to 4.58 and t is equal to 1.42, correct to do decimals. And if we go back and read the question, they tell us that during the first 4 minutes, so this can't work, it's after 4 minutes, t will be equal to 1.42. In part D, we're asked to use integration to find average speed. So this is your 1 over b minus a. In the first 5 minutes will be 1 over 5 minus 0, or just a fifth of the integral. So let's just integrate between 5 and 0. And it's 2t cubed over 3 minus 6t squared minus 13t plus 109 with respect to t. So if we integrate, we're going to get 2t to the power of 4 over 4, but there's a 3 already there, so it's going to be 3 times 4 minus 6t cubed over 3 minus, that's actually plus 13t, sorry, plus 13t squared over 2 plus 109t between 5 and 0. So the 0 won't give me any value here. You could tidy it up a bit. That's going to be 2 over 12, so that's going to be t to the power of 4 over 6 minus 2t cubed plus 6.5t squared. It'd probably be easier to put that into a calculator, plus 109t between 5 and 0, or keep the values in. So this is going to give 5 to the power of 4, 625 over 6 minus twice 125, which is 250. 6.5, I'm not sure what that is, just a calculator that. 6.5 by 25, and then 109 by 5 would be 545. And if we type that into a calculator, we're going to get 112.33, repeating 333. And how many decimals are required? 2. So 112 point, and actually that's bringing in the fifth as well. I've put the fifth in there, divided it by 5, a fifth 0.33 kilometers an hour is the average speed in the first 5. Last part here they throw in, just to separate the guys who know kind of a little bit more knowledge, taking v prime t to be the derivative and v prime prime t, or double prime, to be the second derivative, and v prime 1 is greater than 0 and v double prime 1 is less than 0. 4 graphs are shown. Close to where t is equal to 1, the graph of y is equal to v of t must look like one of the 4 graphs given above. Well, the first bit of knowledge here, if v prime 1 is greater than 0, prime is slope, that means the slope is positive. So let me draw 4 tangents. That's definitely a negative slope. Negative. This one here is a positive slope, so it could be that one. This one is negative, can't be that one. And this one is positive. So we just have to decide between B and D here. And the knowledge that they give us, that v prime prime 1 is greater than or less than 0. That means that the slope is decreasing at this point, not increasing. And we can see here, if I draw the next kind of tangent here, it's going to go towards 0, whereas the next tangent on this one is increasing as it moves along the x-axis. So graph B has to be the one here, and the information here is given as to the reasons why. Slope is decreasing, and therefore it has to be graph B. And that's the end of this question, I think. There's actually another part, so these are only worth 5 each, so 40 so far. So the first part is a junior cert distance, speed, time question, and the second part actually takes quite a while to do for 5 marks. Probably would have given up on it and then come back to it at the end of the test. So let's look at the first one. Average speed zone on a motorway, starting at A and ending in B. Here's A, here's B. It's 10 kilometers long. Cameras record the time taken. Work out the minimum time that the driver could get from A to B while not driving above 100. So it could come in at A at 100 and it could end at B at 100. So what are we looking for? We're looking for time. Time is equal to distance over speed. The distance is 10 kilometers and the speed is 100. So that's 1 over 10 for time, and that's in kilometers an hour. So that will be a tenth, 60 minutes. Did they ask for the minutes? Yep, 60 minutes divided by 10 would be 6 minutes here for part A. And then part B, there's a lot of information here. He passes A driving at 120 kilometers an hour for 2 minutes. So we have speed is 120 and time is 2, but 2 over 60. So we could get the distance traveled in this time. Distance is equal to speed by time. So the distance traveled in the first 2 minutes is 120 by 2 divided by 60, which is equal to 4 kilometers. And 3 out of 5 was for that part. The next 2 marks take a little bit of time, so let's have a look. He starts to decelerate at a constant rate, so he gets to this point after 4 kilometers and he starts to decelerate. He's not going to get to 0, he's going to get to some speed as he crosses B, and they give us his average speed is 100 for the whole thing. Work out his deceleration. So if he's gone 4k, there's 6 kilometers left. That's the first piece of information we can jot down. If his average speed is 100, that's the second bit of information they give us. That's the first part, isn't it? It took 6 minutes in total. So it takes 6 minutes in total, which means he's already gone for 2 minutes. This one here, he's already been on the between A and B for 2 minutes, so there's 4 minutes left. And there's 4 minutes left, and the distance is 6. So we have distance and we have time. Let's have a look at his average speed for the second part. Speed is equal to distance over time. I always shut down the triangle just to make sure. So the distance, 6 kilometers left, and the time is 4 over 60. What's that going to give? 360 over 4. So 90 kilometers an hour is his average speed for the second section. So what's going on here? He started at 120. At the point, well, let's have a look at the diagram. If he goes from A to B, at this point, we'll call this C. So we know the speed at C and we don't know the speed at B. So call this 120 and we call this speed X. So the average speed between these two will be 120 plus X divided by 2, and we know that the average speed is 90. We've just worked that out. So this will be 120 plus X is 180. So this gives me the speed at B. X will be 60 kilometers an hour. So what's happened? He's gone from 120 to 60, and we're looking for deceleration. And this has taken him 4 minutes. So if it's a constant rate, he's gone down by 60 over 4 minutes. So he has decelerated at 15 kilometers per hour. Quite a bit of work on that one. So question 7, I skipped this one, so I'll go back to this one in the order that StudyClix gave it in. So we're given f of x is x squared plus bx plus c, and we're told that the local minimum is when x is 3 and y is minus 1. So f prime x is the local minimum. F prime x has to be equal to 0 to get the local minimum. So if we differentiate f of x, f prime x is 2x plus b. That's equal to 0, and we know that x is 3. So 2 times 3 plus b is equal to 0, meaning b is minus 6. And we know that we have a point on the curve 3 minus 1. So we put x squared plus bx plus c. And if 3 minus 1 is on this curve, we get x squared 9. We have b already, which is minus 6 by 3 plus c is equal to minus 1. So c is going to be equal to 9 minus 18. We're bringing minus 9 across. It's going to become a plus 9. So 9 minus 1 would be 8. So c is 8. And b is minus 6 in this one. The second part, we have a limits question. Find the limit of this guy. Well, if n is tending to infinity, the first fraction, we're going to get infinity over infinity plus 1. Well, that's nearly the same number over the same number, so that's going to be a value of 1. In the second fraction, we're going to get infinity plus 1000 over infinity. So that's like a massive, massive number plus 1000 over the same massive, massive number. That's also going to have a limit of 1. And then the third guy will be different. So that's going to be 1 to the power of infinity, which is just equal to 1 over 3 to the power of infinity, which is a massive number. So 1 over a massive number will tend to 0. So the answer to this one is 2. In the last question, we have Ava looking at the relationship between the factors of 12. So 1 times 12, 2 times 6, 3 times 4 is given, which would be 4 times 3, 6 times 2, and 12 times 1. And you're asked to plot the points in the first part here. So if we plot the points, 112, 2, 6, 3, 4 is given, 4, 3, 6, 2, and 12, 1. It's going to come down. Start here, it's going to come down like this. And connect the last one. Just don't use a ruler. And make those dots visible on your graph. And then there's a couple of questions to follow. So this one is not too bad. They're trying to make these questions look difficult. So that's the first part. In C, we're told a tangent is drawn to the curve at the point, and we're asked to show we're given the answer to the tangent. So, like the previous video, once you see tangent, we write y minus y1 is equal to m times x minus x1. And then we find our point and our slope. So we have the point is given here. So we need the slope of the tangent to the curve. Y is equal to, I'm going to bring the x up, 12x to the minus 1. So dy dx gives me the slope at any point. That's going to be minus 12x to the minus 2, which is equal to minus 12 over x squared. And the x value is p. So m is equal to minus 12. Instead of x, we have p over p squared. So I have my point p, 12 over p. And I have my slope is equal to minus 12 over p squared. Filling that into the equation of a line, we're going to get y minus 12 over p is equal to m minus 12 over p squared times x minus x1, which is p. Multiply this out, we get my y minus 12 over p is equal to minus 12x over p squared minus 12p over p squared. No, plus 12p over p squared, which is going to simplify to be y minus 12 over p equals minus 12x over p squared plus 12 over p. There's one p on top and there's a p squared in the bottom. And we have 12 over p twice. So if I bring this one across, we're going to get y is equal to minus 12x over p squared plus 12 over p plus 12 over p is 24 over p. So that's what we've gotten. And then you go back and you pray that it's the same thing. Y is equal to 12x minus 12x over p squared plus 24 over p. Happy days, we've gotten it right. The last part is area of a triangle. So the area of the triangle formed by the x-axis, the y-axis, and the tangent is k square units, where k is an element of natural numbers. Work out the value of k. Okay, so we have our x and y intercepts. So at this point, x is equal to 0. So what's y equal to? Y would be equal to 24 over p when x is equal to 0. This guy is 0. And then if y is equal to 0 here, we will get 12x over p squared, bringing it to the left, will be equal to 24 over p. So if I multiply both sides by p, I'm going to get 12x over p is equal to 24. So 12x is equal to 24p. So x will be equal to 24 over 12, 2p. So half the base by the perpendicular height gives me the area of a triangle. Half the base is the x value, 2p. Half times 2p times the height, which we got to be 24 over p, is equal to the area. A lot of cancels, so the 2's cancel, the p's cancel, and we're just left with 24 square units.